Project 12 combines components we've used in the past, namely a few LEDs, switch, piezo, capacitor, and servo, but instead of the piezo being used as an output, as a speaker, we're going to introduce it as an input for the first time and talk about the requirements for that. So let's plan this out. I know that we're going to have 3 LEDs, and they're going to come off of 3, 4, and 5. And they're going to be the usual setup that we have for all of our LED kind of parallel arrays that we use. So now that we've got that, those are going to serve as indicator lights to tell you whether a knock is received by the piezo. So the whole idea is you're going to use the piezos to detect knocks, to turn the servo motor so that you could theoretically lock and unlock a particular, I don't know, box or something like that. And to lock it, you'll also use a switch. And we'll go ahead and hook up the switch next because it's got something a little bit new and interesting. Well, actually, I'm not sure if we've used it before, but we'll talk about it no matter what here. Now, the switch is actually going to be hooked up to, of course, power, because how else would it be able to send a current through it? And I'm going to put it on this other side just because it's going to get a little crowded once I get the servo motor in on that guy. And I'm going to throw the switch. Now, I'm just going to throw it up here. I think it's different in your book, but it seems a little bit more out of the way up here to me. All right, so there's a push button switch, albeit a little bit large. And then what this push button switch is going to do is it's going to, on the other side of it, it's going to connect to digital pin 2 all the way over there. So I'm going to go ahead and send that around. I could have put it on that same side, but like I said, I try to keep things from getting extremely crowded. Although they still tend to get pretty crowded. It makes you jump up and over that ground wire. We'll ground this switch here in a second, but that's what's interesting about it. Let's see. Send that down and around. Ding. How to love an Apple Watch. It just never leaves you alone. Okay. So, down. You'll notice that, of course, my drawings tend to look a little bit different than the books because, once again, there's no real right answer other than the fact that you like it to be nice and neat with all the right angles, and you'd like it to be accurate so that somebody could use it to actually draw from it. Now, here's what's new, is I'm actually going to throw something a little unusual here because when we hook up this switch, so normally we would hook, power here on the same side as the bus that we typically power and ground. And then we would go to whatever digital pin like 2 and also to ground through some sort of resistor on this side. And in that case, it would just look like it always has, where the resistor is just in line with ground wire. This one's going to be just a little bit different because instead of having the resistor go to ground on the same side, we're going to pull it across the bridge here and go to the ground on the other side. And that has something to do with something called voltage dividing. And it's really out of the scope of this course. So for right now, just know that if you see it drawn this way, it means you're supposed to send it to the other side. So what this looks like is this is going to be the ground wire. So the ground is going to extend from our others just to keep it nice and clean. And I'm going to pull that up to about where the switch ends. And this is where it's different. I'm going to break out this part from the other side, so from the non-powered side, and I'm going to put a pull down resistor there, and this one is going to be the typical 10 kilo ohm resistor that we use with switches, since otherwise there's really no resistance limiting the current flowing through the circuit, and we wouldn't want to short it out. Okay, so that goes to ground, so we are good for the switch. The next thing we can put in is the piezo. That one's pretty easy. It's going to be a little bit different because usually we don't use a resistor unless we want to, say, control the volume of it. But in this case, we actually want to use it as an input rather than an output, like I said at the beginning. And as an input, it's going to need a resistor to help with the sensitivity. So I'm going to leave my decent sized gap for the speakerish looking piezo symbol. And I want this to connect to A0. So I'm going to have to do a bit of hopping here. I might actually end up having more hops than the books version, but hey, I'm doing this one without planning ahead too, so I'll forgive myself. All right, and this little guy goes down and around to ground, but it's going to have a 1 mega ohm resistor in there to help with the sensitivity. If you put too low of a resistor there, then it won't detect the knocks. This is a 1 mega ohm. Maybe we should review what those colors would look like for the resistor. So 1 mega ohm, mega is a million, so that's 6 zeros. So if I have the beige background, the 4-band resistors, then bands 1 and 2 are our digits, so that would be brown, and for the color guides, look on page 41, then black. Okay, so that takes care of those 2 bands, and then the 3rd band will be the number of zeros. And I've got 1, 2, 3, 4, 5. Let's see, I always work up from red. Red is 2, orange is 3, yellow is 4, green is 5. So this one will be green. All right, if it's a 5-band, so it's the blue ceramic resistors, then the first 3 are your digits. So they're going to be the same, basically brown, black, black. Why do so many colors start with a B? All right, and then the 4th band, of course, will be your zeros. So now I've used up 3 bands, so I'm only going to have 4 zeros, which means it's yellow. Okay, so if you have those resistors, you should be good. It's a little blurry, I think, in the video, but you get it. Page 41 again in your Arduino projects book will have the color guides and probably even just tell you the answers if you need them. All right, and this is going to become my piezo. So the piezo is this weird speakery looking thing. Now, remember, some piezos are polar, and you'll know that one of 2 ways, or maybe it'll have both ways on it. Either the piezo will have one short leg and one long leg, right? Just like always, the long would be your anode and the short would be your cathode. Or it will simply just label the side of the piezo that is positive. Now, I'm actually going to see if I can get you guys the equipment necessary to test your piezos to see if they were labeled correctly, because in my experience, it's not always so. So if you get the project done and it doesn't work and you know it should be working, flip this piezo around and just see if that solves your problem. Okay, piezo placed. Next and last will be the servo with its parallel capacitor. So the servo needs to get power and go to ground. So I'm going to draw this out and cut a little bit into our discussion on resistors there, but not too bad. And I know that it's going to connect to digital pin 9. And it's a pulse width modulator, which is important because we're going to take that analog signal from A0 from the piezo input, and we're going to want to turn it into a digital output that can vary between 0 and 179. And to do that, we have to be able to pulse width modulate it. All right, so let's see. If I want my servo to be there, let's see. Servos are also kind of a clunky symbol. I'm not very fond of them. Sorry about blocking the camera view. Try to draw as nice a looking square as I can, which of course I already screwed up because now it looks like this line's there, but whatever. We'll just color that in and put a darker dot there to indicate that that's where the axes and the little screw holes are. All right, and servos generally have polarity, so check the wires. Make sure you know which one's plus, which one's minus, and which one goes to your data. Okay, so now we'll grab our positive and send it in to the positive side. And now the negative, I need to get it to connect to ground. I guess I can do a triple hop. It's probably why the book did this one first. Whatever. New, 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 and down to ground. No resistors needed on that one because there's plenty of resistance inside the servo motor itself. And so we'll just finish labeling. Servo, piezo, and switch. We'll just call this switch 1, even though there's only one switch. Okay. Yikes. I realized while filming the build for the actual build for this that I forgot to put in the parallel capacitor. There is a 100 microfarad capacitor. Make sure you have the polarity correct. The positive side should be towards the positive side of the wiring. And it is in parallel around the servo motor to serve as a smoothing capacitor to keep the servo from being all jutty and instead moving smoothly along its 180-degree path. Okay, there is the schematic for the Project 12 knock lock.